Ever since ancient times, people have looked up at the night sky and wondered, what's out there? This questioning led to the rise of the field of astronomy, the study of outer space. When people think of astronomy, they often picture someone looking through a telescope like this. But in fact, there are lots of other kinds of telescopes too. The colors of the rainbow make up the optical light spectrum, but did you know there are colors that we can't see, extending from both sides of the rainbow? And these forms of invisible light are often used to make astronomical observations. The three types of electromagnetic radiation, or light, beyond the violet side of the spectrum are called ultraviolet, X-rays, and gamma rays. Telescopes which can see in these kinds of light must be used in space to avoid the Earth's atmosphere. High-energy systems like hot gas, supernova remnants, and hot young stars can be probed using UV, X-rays, and gamma rays. On the red end of the spectrum, there are three more types of invisible light: infrared, microwave, and radio. Infrared telescopes must be located at high elevations to avoid the atmosphere, and they are used to study star-forming regions as well as cool stars. Most microwave telescopes are space-based, and they are often used to study the signature left over from the Big Bang. Finally, we come to the end of the spectrum, the longest wavelength, radio waves. Cosmic radio waves are detected with radio telescopes, large structures that often resemble satellite dishes. Light in this range can penetrate the atmosphere, so most radio telescopes are located on Earth, some at high elevations, some near sea level. Radio astronomy seeks to answer some of the most fascinating questions about our universe. How do galaxies, stars, and planets form? How do pulsars work? What is dark matter? And are there any advanced alien civilizations out there who might want to contact us? Engineers and scientists have built fantastically sensitive and accurate radio telescopes to find answers to these questions. To understand how radio telescopes work, we're going to look at an example: the Green Bank Telescope, or GBT, located in the mountains of West Virginia. The GBT detects radio waves that leave their cosmic source and penetrate the Earth's atmosphere. When these radio waves strike the dish of the GBT, they bounce off and are focused so they can enter the receiver. Once the radio waves reach the receiver, they travel into a funnel-like structure called the feed horn. Inside the feed horn, there's a small piece of metal called a probe, and it detects the radio waves and converts them into an electrical signal. The electrical signal then travels through hardware circuit components which make the signal stronger, so it can be distinguished from the background noise and also filter out any unwanted frequencies. From here, the signal is transferred via cables to a giant supercomputer which transforms the electrical signal into graphs and data that a human can understand. From this data, astronomers can deduce things like the brightness, composition, and speed of their celestial target. Radio astronomy and radio telescopes can tell us a lot about the universe that we could not uncover using optical observations alone. So next time you go out and look up at the stars, remember, there is a whole invisible radio universe out there to explore.